The biggest risk with hybrid systems is the potential for condensation inside the cavity. Hi, I'm Robert Niney, your spray foam advisor and the guy in the Hawaiian shirt. I wear the Hawaiian shirt as a symbol of freedom and flexibility, something that all business owners should want to achieve. You know how most SPF contractors start their business because of their technical skills, but they have no plan for growth? There's no consistency because decisions in their business are made on the fly. They are just trying to get through the day. And they are spread too thin because they do everything themselves. Well, what I do is help SPF contractors like that measure profitability, identify the key activities that drive success in their business, and create a game plan that develops consistency and growth. Let's get into it. Here is some guidance on the proper design and installation of hybrid systems in northern climates. These concepts are based on guidelines developed by SPFA, published in SPFA 147 guidance document, using a series of hygrothermal analysis completed by a consultant, assuming several different failure criteria. We are going to focus on the design of hybrid insulation systems within the building enclosure with the intent to target code-required R values and minimize the potential for condensation and air leakage. As previously discussed, a hybrid insulation system uses a partial fill of spray foam to reduce air leakage and provide a portion of the total R value, and then adds fibrous insulation to provide additional R value. Generally, the SPF is installed in the cavity first against the exterior sheathing, and the balance of the cavity is filled with another type of insulation, which could be fiberglass batt, blown-in fiberglass, rock wool, wet spray cellulose, dense pack cellulose, another type of spray foam, or reflective insulation. When using hybrid insulation systems, we are generally concerned with three key design elements: the project climate zone, the R value, the interior humidity and temperature conditions. The project climate zone is important because different climate zones require different approaches to designing these hybrid insulation systems. The R value has two critical components, specifically the total code-required R value and the minimum spray foam R value for condensation control based on climate zone and the total cavity R value needed. And finally, the interior humidity and temperature conditions determine the failure points. The biggest risk with hybrid systems is the potential for condensation inside the cavity. We must start our assumptions somewhere, so we typically begin with typical operating conditions for residential homes. Unusual occupancies with higher relative humidity, larger temperature differentials, or special designs like pool areas or cold rooms will require additional analysis. When designing hybrid wall applications in climate zones 4 through 7, one key distinction is whether we need to add a vapor retarder on the interior side of all of the insulation. For example, if you are using an open cell spray foam as an air seal and insulation in combination with vapor permeable insulation, a Class 2 vapor retarder should be used on the interior side of all of the insulation in climate zones 4 through 7. In this scenario, we would install the greater of 2 inches minimum open cell spray foam, the minimum thickness to qualify as an air-impermeable insulation, and the minimum recommended application thickness. And then we would fill the remainder of the cavity with additional insulation and install at least a Class 2 vapor retarder on the inside surface. This same method would also apply when we use closed cell spray foam at a thickness that does not achieve a less than 1 perm vapor retarder. For example, if we only install 1 inch of closed cell foam for the air barrier qualities, and then we fill the cavity with additional insulation, we would need to install a vapor retarder on the inside of all of the insulation. We can also create a hybrid design with closed cell spray foam where the use of an additional interior vapor retarder is not necessary. By following this table, we can quickly determine the minimum spray foam R value compared to the total installed R value needed to minimize the risk of condensation in these given climate zones. Overall, there are several factors that determine the minimum recommended design thickness for hybrid applications. In climate zones 4 through 7, the design thickness can be determined by identifying the greater of the minimum thickness to qualify as an air-impermeable insulation, the minimum manufacturer recommended application thickness, the minimum thickness to qualify as a less than 1 perm vapor retarder, or the percentage of total installed R value for the specific climate zone based on the table that we just looked at. Let's look at an example of a hybrid application in climate zone 5A like Albany, New York, with an R20 wall requirement. Upon discussion with your SPF supplier, you discover that their closed cell foam has been tested as air impermeable at 1 inch thick. It has a minimum recommended thickness per pass of 3/4 of an inch. It achieves 1 perm at 2 inches, and 40% of the required R20 is R8, which would be about 1 1/4 inches of their closed cell foam. By reviewing this table, you can quickly see that the greatest thickness of these categories is 2 inches because that's what's necessary for the product to achieve 1 perm. So, one more check in this analysis. Based on the climate zone table we looked at earlier, the R value of this 2-inch spray foam application must be at least 40% of the total cavity R value. So if this 2-inch closed cell spray foam application is an R13, then the total cavity R value for this climate zone would have to be less than R32.5. In this part of the country, most walls are 2x6 wood studs, which gives us a cavity space of approximately 5.5 inches. So we can apply 2 inches of this closed cell foam in the cavity and fill the remainder of the cavity with up to an R19 of another type of insulation and have little risk of condensation in this climate zone without adding an additional vapor retarder, because the closed cell spray foam in this situation provides the vapor retarder. While this is a standard way to approach a hybrid insulation application, as with any application, make sure that the path you are taking meets local building code requirements. Additionally, remember that the minimum recommended design thickness is going to be dependent on the specific spray foam products you are working with. So consult your supplier or review their technical documents to answer the questions previously discussed to make sure you are using the right thickness of your materials. You have just watched an excerpt from one of my live trainings. Like this video and make sure to subscribe here on YouTube so you are notified when we release future videos. And if a strategy discussion might be helpful for you and your business, you can book a call with me at spfbiz.com.